last time we were looking at the transformations, and in the transformations, I remember telling you that we basically have four types of transformations that we look at this level. Those are the translation, we have the enlargement, we have rotation, and reflection. So, among these types of transformations, I think we looked at all of them. We looked at all of them and how best we can get the translation matrix or the translating matrix if we are given one. In the last lesson, we looked at the graphical bit of it, how you use the graphs to come up with a matrix of reflection in the lines that are, as the lines we looked at, the line x plus y is 0, the line x minus y is 0, or the x-axis and the y-axis as well. We continue to look at the rotation bit of it, how the values are rotated. If you have I and j, how do you rotate them and to come up with a transformation matrix rather. So in that lesson there is a bit of there is something that we need to look at. In other words, time did not allow us to look at it, but basically was about the area scale factor. You ask yourself, how is the area scale factor related to the transformations? We are going to look at it. So today I've decided to take us into the revision question. We are going to look at different categories of questions. To start with, we are going to look at the relationship between I'm going to do one example in each category, but you are supposed to do as many examples as you can on those questions that I gave you when you were going back home. So I'm going to do some little bit of transformations and how area scale factor, how are they related, and then I will go to the sets, and finally I will come to functions if time allows us. So for starters, if I talk about linears, when you look at your screen, there is an example that is under transformation T of matrix T. They gave us that matrix, as you can see it there. A figure whose area is 4.5 centimeters squared is mapped onto a figure whose area is 54 centimeters squared. Find the possible values of x. Now they're asking for the possible values of x, but we should know that in mathematics we always have what we call the linear scale factor. And the linear scale factor in mathematics is always, it has some relationship. We have the linear scale factor, we have the area scale factor, and we have the volume scale factor. For starters, these are the common measurements that we use, or the common things that we normally use. But these ones must have relationship. The linear scale factor is related to the area scale factor, and the same linear scale factor is also related to the volume scale factor. Why am I bringing this in? We know that in transformation, like for a bit of enlargement, we looked at the linear scale factor. But here, you should know that the relationship that the linear scale factor, when I talk of a linear, let's say we have a triangle and another big triangle, the same shape. This is maybe 5 centimeters and this is 3 centimeters. Yeah? This is x and this is 4 centimeters. Then they ask you to find the value of x. Here you're going to use linear scale factor because these ones are the same. So you use their linear scale factor. In other words, they are related, but you use their values. This one is related to this. This over this is equal to this over this over this is equal to this over this. So you use those similarities and you deal with them. They are linear. In other words, they don't have any other units like squared or cubed. They are linear. In other words, they are given as they are supposed to be. So that's why we call them linear. But if at all, what you should know is that the linear scale factor is equal to the square root of area scale factor. If I want to get the area scale factor, remember areas are in form of centimeters squared, and linear they are in centimeters. So if I want to equate this and this, I would say this is equal to the square root of this. Because if I get the square root of this centimeter will go with that, and it will be centimeters equal to centimeters. Hope you can see that. So area scale factor, linear scale factor is equal to the square root of area scale factor, or linear scale factor squared is equal to area scale factor. In other words, you square this. These are the referring to the linear scale factor 2 and equaling to the volume scale factor. These are the same. Don't be confused. They are more of the same. So you can use any of the two. Why am I telling you this? Because you may come across a question which may not be part of this transformation, but you may come across a question there and they're giving you that two teams. You have a first team, that is this, and another team. They have the same shape, but they are of different sizes. This one has a volume of, let's say, of 400 cubic units here, and this one has a volume of 5,000 cubic units. Then they give you, like, let's say the radius of this team is 14 centimeters, and they tell you that this radius is x. They ask for x. How do you do to get the value of x? You remember the teams are of the same shape, but in this case, having the same shape, but they are of the same shape but of different sizes. So what you do, you'll come and say that linear scale factor is equal to the cube root of volume scale factor. Or you can say that linear scale factor squared, you use the simplest method for you. Or you can say that linear scale factor cubed, let me use linear scale factor cubed. Linear scale factor cubed is equal to the volume scale factor. So after this, I will have to get the linear, which values are linear. So I will say that the radius of the big cone over the radius of the small cone is equal to the volume of the big cone. Now you should be careful here. If you start with radius of a big cone over radius of a small cone, in the same way this side you should start with volume of a big cone over the volume of the smaller cone. And then you will say that the radius of a big cone, which is 14, over radius of the small cone, which is x, is equal to volume of a big cone, which is 5,000, over the volume of a small cone, which is 400. So here you cross multiply and come up with the value of x. Remember, this one is supposed to be cubed. This one is cubed. So you'll have to deal with it, and any value that you get will be centimeters, just flat. So if the value of x will be in centimeters. So that was an example that I was trying to look at, relate the volume scale factor and the linear scale factor. The same applies to area. If you have a figure and they are talking about area, then they want you to find the other. It's this that you're supposed to use. These questions are very common in section A. So now, I'm going to take us into the questions that we have there. Okay. Now, for the first question, they are telling us that under transformation of t, the transformation is t is equal to x minus 1, x, 2, and x. Then they are telling us that a figure whose area is, so the area of the object is 4.5, is mapped onto a figure whose area is, so the image has an area of this. Here you should know that under translation, the area scale factor is equal to area of the image, over area of the object, over area of the object, area of the image over area of the object. So area of the image over area of the object. Sorry for the volume, it was very low, but I think now you can hear me. So the area of the image over the area of the object, that is what area scale factor is equaling to. So to continue, you should also know that when you have a transformation matrix T, how is the transformation matrix related to the area scale factor? You should know that the transformation matrix, rather the area scale factor is equaling to the determinant of the transformation matrix that is in question. How do we get the determinant? Entries major diagonal the product of the major diagonal minus the product of the minor diagonal. That's how we come up with the determinant. So to get the area scale factor while having a transformation matrix, you get the product, or you get the determinant of the transformation matrix. It will be equivalent to the area scale factor. So in this case, and we know that area scale factor is area of the image over area of the object. So you can simply relate to that. So don't forget that if you have questions, please write them down there in the comments and I will have to reply them. So here I'm basically going to look at the area scale factor, which is area scale factor is equal to area of the image over area of the object. Is area scale factor is equal to the determinant of the determinant of this, in this case the determinant of the transformation matrix here. So the transformation matrix is that one. So the area scale factor is equal to the determinant of this. How am I going to come up with the determinant? We know that area scale factor is area of the image over area of the object. What is the area of the image? The area of the image, according to the question, is 54. You should be very keen when you're looking at it, because here they are telling us that a figure whose area is 4.5, meaning that that is the area of the object, is mapped onto a figure whose area is 54. So this onto is the area of the image. It is area of the image over area of the object, which is 4.5. They are centimeters squared, so they will go is equal to the determinant of this. How am I going to come up with the determinant? The determinant is going to be x minus 1 times x. Remember, it is this times this minus it is the product of this major diagonal minus the product of the minor diagonal, which is this times this. So my 54 over 4.5, in other words 54 over 4.5 is 12, if I'm not mistaken. Over 4.5, the answer is 12. Yeah, so this one is going to be 12. I'm going to write 12 straight away, and this is going to be, when I multiply x with this bracket, it's going to be x squared minus x. It is x squared minus x and minus 2x. I can remove the brackets because I already have one term. So this one, this x has multiplied the whole of this bracket, and I've come up with x squared minus x minus 2x. So I'm going to collect like terms. You can see that I'm trying to form a quadratic equation here, which quadratic equation is going to be x squared minus x minus 2x, x minus 2x. I don't need to waste time here. X minus 2x, this is going to be negative 3x, is equaling to 12. Now I've started with this side, and I'm bringing in this side. So I'm going to bring this 12 this side, and it will finally be x squared minus 3x minus 12 is equaling to 0. Now when you try to look at our quadratic equation that we have, I want us to deal with it. How are you going to deal with it? You can use factorization method. Another person can use the formula method, which you commonly use, called bulldozer. There is also another method which is completing of squares, and of course you cannot use quadratic curves here. Quadratic curves are normally used in section B, but here you can only use basically three methods, that is completing squares, the formula method or bulldozer, and the factorization. Now let me first use the factorization method here. When I'm using factorization, I get two numbers with a sum of negative 3 and a product of 12. What are those numbers? The numbers are, when I try to look into the factors of 12, I will look into the factors of 12, which are 1, 2, 3, 4, 6, and what? 6 and 12, of course. The two numbers, when you add them, you get negative 3, and when you multiply them, you get negative 12. What are those two numbers? I have I can first list the factors of 12, because I get them from the factors of 12. 1, 2, 3, 4, 6, and 12. So I try to see. Now what if I get 6
6 is can give me 12 when I relate it with the 2. Then 4 and 3. 4 and 3, can they give me negative 4 and 1? No. What if I get you look into the question and you see the factors that will give you the answer that you're interested in. Here this is negative 3. Negative 3, yes, negative 3, it is okay. Then when this one comes this side, it is negative 12, yes, that is it. Then you come up with the factors. 12 and 6, 12 and 4, no, 3 and 5. I think the factors are not here, so I'm going to go and use the completing squares. There are very many methods. I'm going to use the completing of squares if I fail to come up with the factors. How am I supposed to use when I'm using the completing of squares? The first step is to make this one 1. This one is already 1. Then the second step will be get the value of the coefficient of x, divide it with 2, and then square. So what is the coefficient of 2? But I don't take it with its sign. Instead, I just take the number here. What is the coefficient of the coefficient of x is 3, negative 3 in other words. But I don't take the negative bit of it. I just take the positive. I just take the 3 without a sign. Yeah. So I'm going to say I get 3 divide by 2 and then I square, which will be 9 over 4. Now after getting the 9 over 4, you come here after this, add and subtract it. So it's going to be x squared minus 3x plus 9 over 4 minus 9 over 4 minus 12 is equaling to 0. After coming up with this, you're going to take this, you're going to form a perfect what? Square. You can all see that this is a perfect square. What do we mean by a perfect square? Something that can simply give you a square. So a perfect square is x minus, I take the sign here, I don't take any other sign, but instead I take the sign here and I go to this before opening it. So it is 3 over 2. When you try to multiply this one, you go back to this. I don't have enough time to do it for you, but I think you know it because we looked at this formula, this method here with you people. So this one is x. I take this x as it is without a square, take the sign next to it, which is minus, and I take this one as 3 over 2. Close brackets, squared, minus 9 over 4. I continue with this, minus 12 is equaling to 0. Then I'm going to push these ones the other side. I will come up with x minus 3 over 2 squared is equaling to 9 over 4 plus 12. So x minus 3 over 2 squared is equaling to, the LCM here is 4. 4 divided by 4 is 1. And 1 times 9 is 9, plus 4 divided by 1. 4 divided by 1 is 4. And 4 times 12, we will get 48. So it's going to be x minus 3 over 2 squared is equaling to 57 over 4. Find square root, find square root. So x minus 3 over 2 is equaling to the square root. This is 7.54998 plus or minus over 2. You know that the square root of this is this over 2. Yes. Now I'm going to shift this the other side, and I will say that x is equaling to plus or minus 7.5498. You see, I'm trying to round off to at least 4 decimal places, over 2 plus 3 over 2. When this one crosses the equal sign, this is plus or minus. Yeah. Now, when I try to come back onto, okay, let me write here Hope you can see this place very well. So this is going to be, for x1 I'm going to take the positive part. X1 is going to be, I'm taking the positive part of 7.5498. So it is 7.5498 over 2 plus, because this is plus, it was a negative here, plus 3 over 2. So x1 will be, you just add the numerators, 7.5498 plus 3, the answer will be 10.5498 over 2. So x1 is finally 5.2749. That is x1. Then you come up for you look for x2, which x2 is going to be, the x2 is equaling to the negative bit of this, negative 7.5498 over 2 plus 3 over 2. When I try to subtract the negative 7.5498 the answer is x2 is equal to negative 4.5854498 over 2. And then finally x2 will equal to 5498 negative 4.5498 divided by 2. The answer is negative 2.2749. So therefore the values of x are, x1 is 5.2749 and x2 is negative 2.2749. So those are the values that I've got. So here, according to my example, those are the two values that I have for x. I put a comma in between them and I write both of them. So those are the two values of x that I have. Now you can come up with another question. In the questions that I gave you, can look for those questions and you try them out using different methods. But we've realized that now the factorization method could not work out this question. Instead, I decided to use the completing of squares. Now there is no number that you can fail to do if you know all the methods. If this one is so hard for you, please go in for the formula method, or what you commonly call the bulldozer. Now I'm going to look at part number 2. Time is not my best ally. Allow me to look at number 2 very fast. So I don't know whether I have any question. Please, if you have questions, write them in the comments before I proceed to another question. Do I have any question on that? Okay. So the population of a certain town, now I'm looking at set. I think you can see on your screen there is an example there on the screen there. Let me hope you can see it very well. The population of a certain town has a choice of 3 daily newspapers: a New Vision, the Monitor, and Book a Day. 40 read New Vision, so the number of New Vision is 40. Number of New Vision is 40. They continue to tell us that 35 read M, which M is Monitor. Number of Monitor is equaling to 35. They also tell us that, and 60 read Book a Day. You can see. So there are 60 people who read Book a Day. They tell us that 7 read New Vision and Monitor. So the number of New Vision intersection Monitor is equaling to 7. Continue to tell us that 10 read monitor and book a day. Number of monitor intersection book a day is equaling to 10. And finally 4 read new vision and book a day. So the number of new vision intersection book a day is equaling to 4. Then 34 read no newspaper at all. So the number of new vision complement intersection book a day complement intersection which other paper monitor complement is equaling to 37. They're telling us that 34 read new paper at all. They are 34. Okay, 34. If there are 150 people in the town, so the number of summation is 150. So this is the information that was given to us, and they want us to write to find the number of people who read all the 3 newspapers. Now here we are going to draw a Venn diagram as we normally do. So as I told you that normally when you're dealing with the sets, you draw 3 sets. Normally at this level in section B they give us 3 sets. So you draw them like this and always enclose them. Okay? Enclose them. Need to use even the other parts. Okay, so I'm going to draw 3 sets. Always enclose them. Okay, enclose the 3 sets. So start filling in, starting with the summation if you have it. If you don't have it, please don't write anything there. Summation which is 150. Okay, some of you have a tendency of using pencils to fill in the set. Please use your pen to write in the set. So the number of summation is equaling to 150. Then they tell us that number of those who are reading new vision is 40. Number of those who are reading monitor. Now some of you have a tendency of writing monitor, but it is supposed to be number of monitor if they have given either those who eat this or those who read this. And then finally the number of those who are reading book a day is 60. So we proceed. Now I remember telling you that after this you go through the question looking for the intersection. If you have it, you go through the questions and you look at the intersection. If you can't see the intersection, look into the questions. They're asking for the number of the people who read the 3 papers. They commonly ask that. So you come here and know that these ones are not there, so you let them to be any unknown. In my case, I'm letting them to be X. I'm letting them to be X because X is simpler for me to deal with. You can also let it to be Y or any other letter. It's okay. So I'm letting them to be X. Now, after letting them to be X, they continue to tell us that 7 read new vision and monitor. But they are not telling us that they read new vision and monitor only, but they are telling us that 7 read new vision and monitor, just that. So if the 7 read new vision and monitor, the 7 are supposed to be here, but you're not going to write 7 like that, because it includes all the members. Also these ones that read new vision and monitor, but they also read some little bit of book, they are included in those 7. So if there are 7 people who read new vision and monitor, you are supposed to write here 7 mark, supposed to be 7 minus X. I don't know whether it is visible. It is supposed to be 7 minus X. You can ask yourself, why am I subtracting X? I'm subtracting X because they have not told me that 7 read new vision and monitor only. But if they tell you that 7 read new vision and monitor only, then you write the 7 there. But if they just tell you that they read new vision and monitor, it means that they are also these ones that read some bit of Booked are included in those ones. There are some members here that read Booked and they read the Booked, new vision and monitor. They are included in this set. So if they say that if they want you to write a 7 there, they will tell you that 7 read new vision and monitor only, or they will tell you that 7 read new vision and monitor, but not Booked. Those are the two words that they basically use. Or they tell you that 7 read new vision and monitor without Booked, or leaving out Booked. You'll have to know that Booked is left out, and you'll have to write that 7 alone. 7 minus x. Okay, I'll proceed. Another one is telling me that monitor and Booked, they are 10. So I can now write here monitor and Booked 10 minus x. You know the reason as why I'm not writing 10 alone. I'm subtracting off these ones. Then, and there are 4 people who read new vision and Booked. New vision and Booked. So 4 minus x. So I need to fill these spaces here. There are 34 people who do not read any of the 3. I can write the 34 here or there. It is okay. So I need to fill these spaces. Another person can choose to let them x, y, z. You should be also be mindful of the x that you use. Yeah, I'm using this type of x everywhere, not using the other type of x and then at other point you use another x. So I'm using that one in particular. So I'm going to find the value here, here, and there. I don't want to put in, another person can put in A, B, C, but me, I want to find the value straight away. How am I going to find it? I know that the whole of this set is 40, but if I have this and this, I can get the value here by subtracting 40. By subtracting these whole values that I have from 40, I will come up with the value here. So 40 minus, I open brackets, 7 minus x plus 4 minus x plus x. Negative, positive will go, and I'll have 40 minus, what is this? 7 plus 4. The answer is 11. I have minus x. So this 40 minus 11, the answer will be 29. Negative times a negative, the answer will be positive x. So this is for the first value. So here, for the value of 40, this one is supposed to be 29 plus x. When I subtract 40 off when I subtract these ones off 40, the answer here is 29 plus x. When I proceed, I'm going to get the value here and I subtract these ones also. So it is 60 minus, open brackets, 4 minus x plus 10 minus x, close brackets. I get this and I subtract these ones, yeah? This and that. In a bracket, I must put them in a bracket. Don't leave out the bracket. I'm putting much emphasis on this. You must put these ones, others, in the brackets. So it is 60 minus, this will go with that. This will be 14. When I add this and this, minus x. And then 60 minus 14, the answer will be, I think the answer will be 46. Yes, 46. So the answer here is going to be 46. This minus this, it is positive. It will be positive, yeah? So here I will have 46 plus x. And when I proceed, I need to find the value here as well, which is going to be 35 minus 7 minus x plus 10 minus x. This will go with this. I will remain with 35 minus this, and this will go. It will be 17 minus x. And 35 minus 17, it will be 18 plus x when I subtract these ones. So my answer here is 18 plus x. Okay, so that is the set. that we were looking at. So after getting these ones, these values here, I can simply work out the value of x. Okay, how am I going to work out the value of x? I'm going to get all of these ones, equate them, and equate them to the summation, which is 150. Then I will be getting the value of x. These ones you must also show them in your working. Don't put them on a side. You must put them below the set and you show them. Okay, you must show them below there and you feed in the set. After feeding in this, please, even if you come up with the values of x, don't congest your set. Don't write any other thing in that set. Leave it as it is there for the examiner to come and mark that. They will mark that. Leave that. Don't feed in any other thing. Some people have a tendency that after getting x as 2, you say that this is 16. This is after getting x as 2, you say this is 20. This is 48. This is 8. This is 5. This is 2. Please don't congest your set. Don't fill any other thing. Leave the set as it is there. Don't fill in any other thing. So I'm going to wrap this off because I want to use this part, but basically you should know that this thing should be on your paper, on your answer sheet below the set. So I proceed. On proceeding, I will say that I'm going to find the value of x. Which value of x is going to be? I'm going to say it is 29 plus x plus 7. Don't know what is wrong with the mark here. Okay, 29 plus x plus 7 minus x plus 7 minus x, this plus this plus this plus this, plus x plus 4 minus x plus 18 plus x plus 10 minus x plus 6 plus 46 plus x plus 34. Some of the people forget this value outside is equaling to 150. Now some of you fear these long things, but they are always simple. You can always make them simple. Look for the positive and negative. This one is positive and this one is negative. They are going away. This is positive and this one is negative. They go. This is positive and this is negative. They go. You remain with x alone here. Consider I have any other x. This one and these ones have gone. This one and this one, they go. This one and that one, they also go. So this goes with this goes with this, and this goes with that. I mean with 1x. So I'm going to, from here I can simply also add these ones straight away. So 29 plus 7 plus 4 plus 18 plus 10 plus 46 plus 34. So the answer is 148. So the answer is 148 plus x. Remember I have only one x, which is this, plus x is equaling to 150. So I take this one the other side. My x is going to be 150 minus 148, which x is going to be 2. So after coming up with the value of x as 2, you all know that now x is 2. You can find the other questions as they are going to ask them to you. Now the first question is telling us number of people who read all the 3 newspapers. I think we've come up with it. Then part B, they are telling us number of people who read only one newspaper. So the number of people who read only one newspaper, which is part B, those who read only one newspaper are, we have these ones, and these ones. They read only one newspaper. So it is 29 plus 2. What is this? This is supposed to be 31 plus, who read only one newspaper, this is 18 plus 2, which is 20 plus this is 48. Number of people who read only one newspaper. So you get the answer as, I'm trying to be brief here, 20 plus 48. So there are 99 people that read only one newspaper. Only one newspaper. These ones, and these ones. And the part B, they are telling us number of people who read N and M only. Who read N and M only. They read N and M only. So they don't read any other party. So it is 7 minus X, which is 7 minus 2. And the answer will be 5 people. So we have 5 people who read those two only. They are basically 5 people. Some people, if they say N and M only, he will get this one only and this one only and add them. That is wrong. If they say N and M only, it means they are talking about the intersection here. But this point. So they say the probability of a person chosen at random, if a person is chosen at random from the towns, reads 2 newspapers only. So how many people that we have that are reading only 2 newspapers? What is the probability that that person reads 2 newspapers only? Probability that they read 2 newspapers only. How am I going to come up with that probability? Remember that probability is equal to total number of events. Total number of events over the sample space. Over the sample space. So, what is the probability going to be like? Total number of events. We have this. The number of, find the probability that the person chosen at random reads 2 newspapers only. This one reads 2 only. This one, this one. So we have 3 categories. And this is 5 plus this is 8 plus this is 2 over the sample space, the number of people in that town. So it's going to be this is 15. So 15 over 150. Remember, probability is always given in its simplest form, but you don't give it as a decimal. In other words, we leave it as a fraction in its simplest form. I have 20 minutes. Okay, I have 20 minutes to go. So 15 divided by 150, the answer is 1 over 10 as our probability. So that is the answer. The final answer is supposed to be 1 over 10. Don't leave it at this. You won't get the accuracy mark. The accuracy mark is put on this. Okay, so you should be very keen here. Here you won't get the accuracy mark if you leave it at this. Okay, so the answer is 1 over 10. You must always you must always simplify the fraction. You must give the fraction its simplest form so that it is no longer divisible with any other thing. Then we continue. I want us to look at, in the last 20 minutes that we have here, I'm going to look at a small thing to do with functions. Now I think functions, you can look at your screen. There is something that you're seeing there on the screen. There is a question for functions there on your screen. I haven't seen any question today, so I don't know what's really happening. So on the function that we have, time is not our best ally, and I want to use these 20 minutes that I have effectively, such that I don't enter into another person's time. Okay, so here we have that f of x is equal to the function f of x is equal to 14x over x squared minus 9. Okay, part A, find f of 4. They are telling us to find f of 4. Find f of 4. How do we get f of 4? So f of 4, it means that you can look at f of x. Now when you compare these two, it means that where I have x in this equation, I'm going to put there what? 4. So it's going to be 14. I think you all know that here there is a multiplication sign, times 4 over 4 squared, which is x squared minus 9. So f of 4 will equal to 14 times 4, the answer is 56, I think, over this is 16 minus 9. So because 4 squared is 16, so f of 4 is going to be 56. What is 16 minus 9? The answer here is 7. So you get 56 divided by 7. F of 4 will be 8. Okay, f of 4 will be 8. 56 divided by 7. The answer is 8. Yes. So that was the answer that you were supposed to get for f of 4. Now after getting f of 4, remember I told you that you should avoid the things of crossing into the answer sheets. Always calculate while moving down. But since I have a small board here, I don't have any other option, but instead I will have to cross and use this part as well. So the value of x for which f of x is meaningless. Now I tried to explain this in some of the streams, but when I was marking the mock exams, I realized that some of the people did not understand what exactly I was trying to mean. Now I tell you that the function is always meaningless if the denominator is equaling to 0. It is only the denominator that is equaling to 0. Now I can give you a task. If you have a calculator there with you, try to get any number like 8 divided with 0, and you see what they are giving you on a calculator. They will give you math error. And that math error, it means that the calculator cannot compute that. In other words, it is meaningless. Okay? If I have any other value, 8 over 0, it is equaling to infinity. In other words, they tell you that it is meaningless, or it is undefined. There are two words that they basically use: meaningless, undefined, and so on. Or it is infinite. In other words, the answer cannot be got like that. If you try to put it on a calculator, they'll give you math error. Okay? So here, if I have a function like this one, and they tell me that it is meaningless, it means that the denominator is equaling to 0, just like that. The denominator is equaling to 0, period, not any other thing. So if you have a function in form of f of x is equaling to 14x over x squared minus 9. Some of you were saying that the denominator is equaling to 0. You really understand, and someone equates it in this form, over 0. This is wrong. Please don't put a 0 here, but instead what you're supposed to do, if you know that the denominator is 0, get the denominator. What is the denominator in this case? It is x squared minus 9. Get it and say x squared minus 9 is equaling to 0. They always ask for the value of x if the function is meaningless, so just get the denominator. The other one, you don't need it. You just need to get out the denominator and you equate it to 0, such that you get x. You can use two methods here. You can use the difference of two squares, which will be x plus 3, x minus 3. I can say that x plus 3, x minus 3 is equaling to 0, and say that either x plus 3 is equaling to 0, or x minus 3 is equaling to 0. So x1 is equaling to negative 3, and x2 is equaling to 3 when these ones cross. Or another person can get it from here and say that x squared minus 9 is equaling to 0. Transfer this 9. X squared is equaling to 9 when it comes this side. It is 0 plus 9, which is 9. Square root. So x will be plus or minus 3. x1 is equaling to 3, and x2 is equaling to negative 3. Both answers are the same. So you can use either this or this. You come up with the same answer. So if they tell you that the function is meaningless, you just get the denominator and you equate it to 0. Not any other thing. You just get the denominator, this one, and you equate it to 0, like the way I've done here. Here it is starting from here. You just get the denominator and you equate it to 0. You don't need to put 0 here like some of you, the way you were doing it. So I'm going to proceed. I think I've used my time very well. I'm going to proceed, and I'm going to finish up with this part B. I think it is the last part. part B, as you can see it there. For part B, they are telling us that determine the range corresponding to the domain, this and this, for the mapping x represents, or x is mapped onto 10 minus 2 under the square root of x with the product of the root of x. So here it's going to be, remember we are supposed to draw two parts here, draw this and that. Okay, this is the domain and this will always be the range. Don't forget to name them. You name this one as the domain and this one as the range. You put up here the mapping that they have given you. X is mapped onto 10 minus 2 under the root of x. This is the range. Okay, and the domain is, the domains are there. I think there are 3 numbers. Yes, so here the range will also be 3. So don't forget to put the arrows as they are supposed to be. So the domains are 4, 9 and 16. I need to come up with a range. Now when x is when x is equaling to 4, you can see that here when x is 4, what do I get for the value of this when I put x into this? So 10 minus 2 into square root of x will equal to 10 minus 2 into square root of 4. Now I'm just substituting this x. So we are saying that when x is 4, I'm just substituting where there is x to put there 4 in this equation here, in this expression here, in other words. So I'm trying to remove the x and put there 4. So this is going to be 10 minus 2 times 2, which is 10 minus 4, and the answer will finally be 6. So it means that here you are supposed to have 6. We proceed. When x is what? We proceed when x is 9. When x is equal to 9, you will say that the expression 10 minus 2 into root x is equaling to 10 minus 2 into root 9, because you already see that x is 9. So I'm substituting where I have x, put there 9. So this is 2 minus 2 times 3, and this is 10 minus, what is this? This is 6. The answer is going to be 4. So here the value is 4. We proceed when x is equal to 16. So 10 minus 2 into x is equal to 10 minus 2 into 16. This is 10 minus 2 times 4. This is equaling to 10 minus 8, and finally this will be 2. So the answer there is 2. So the values for the range are 6, 4 and 2. You've come up with the range values after using the domain. But don't forget that here you must name this one as the domain and this one is the range. You put the arrows that this one is coming from here and it goes there. It is mapped onto this, it is mapped onto this, and you must put this up also to show the mapping that you're dealing with. So I requested you to send me the questions that you have, but I think you don't have questions here. If I have any question, I think I'll have to answer it before I get off. That's what I had for us today, but let me see if I have questions here in the comment section. So if there is any question, there is no comment, or there is no question that I've seen now, let me wish you a blessed day until we meet again, inshallah. Assalamu alaikum.